Here our topic is about ferromagnetism in memory storage devices. Here is the introduction for the topic. Memory storage devices got originated due to the invention of ferromagnetic materials. There are various kinds of magnetism, out of which ferromagnetism is the strongest type. Ferromagnetic materials are those materials which exhibit a spontaneous net magnetism at the atomic level, even in the absence of an external magnetic field. First, let us see what is meant by ferromagnetism. Ferromagnetism gets its name from the word ferrous, which means iron, which was the first metal known to show attractive properties to magnetic fields. Ferromagnetism is a unique magnetic behavior that is exhibited by certain materials such as iron, cobalt, alloys, etc. It is also described as a process where some of the electrically uncharged materials attract each other strongly. Then let us see what are the causes of ferromagnetism. In a ferromagnetic material, in the unmagnetized state, atomic dipoles in small regions called domains are aligned in the same direction. The domains exhibit a net magnetic moment even in the absence of an external magnetic field. On applying external magnetic field, these domains align themselves in the direction of the applied field. In this way, the material is strongly magnetized in a direction parallel to the magnetic field. Then here we can see images. First is image is about random domain orientation, and second is image is about after magnetization. Then what are ferromagnetic materials? Ferromagnetic materials are a certain group of substances that tend to magnetize or display strong magnetism in the direction of the field due to the application of a magnetic field. The cause of the magnetism in these materials is mainly due to the alignment patterns of their consistent atoms. Examples are such as iron, cobalt, nickel. Here are some properties of ferromagnetic materials. The atoms of ferromagnetic substances have permanent dipole moment present in domains. Atomic dipoles in ferromagnetic substances are oriented in the same direction as the external magnetic field. The magnetic dipole moment is large and is in the direction of the magnetizing field. The intensity of magnetization M is very large and positive and varies linearly with the magnetizing field H. Hence, saturation depends on the nature of the material. Here are some applications of ferromagnetism. There are numerous applications of ferromagnetic materials for magnetic storage, electrical and electromechanical equipment. Permanent magnets. Ferromagnetic materials are often used for making permanent magnets because their magnetization lasts longer. Then comes transformation core. Electromagnetic materials are suitable for making the transformer core and choke, which is subjected to very rapid cycle changes because of its strong magnetic induction. Magnetic tape and memory store. It will serve the purpose of a memory storage unit as the magnetization of a magnet depends on the magnetization field and the magnetization cycle it has undergone. Therefore, the magnetization cycles that it has undergone are recorded as the specimen's magnetization value. Here we can see an image of 2D ferromagnetism, where we can see device integrations, physical properties and material synthesis. Memory storage devices. Magnetic tape, a plastic film with a magnetic surface, was used. It did not have a scattering problem of stacks of cards. Some early computers used core memory. Small critical ferrite cores were used to store data. A large improvement was the development of hard disk and aluminum platter covered with a magnetic film. This had the advantages of holding more data, allowing faster random access to different areas of the data. The second item was bubble memory. On a silicon substance, a racetrack style layout was created that allowed bubble memory to travel around. Coming to the conclusion, ferromagnetism refers to a physical phenomenon in which certain materials like iron strongly attract each other. Ferromagnet occurs in a rare materials and gallium. Ferromagnetic substances show permanent magnetism even in the absence of magnetic field. The main cause of ferromagnetism arises due to the interaction between the alignment of permanent dipoles in atoms and the neighboring atomic dipoles. There are numerous applications of ferromagnetic materials for magnetic storage, electrical and electromechanical equipment. Magnetite is a ferromagnetic material that is formed by the oxidation of iron into an oxide. Thank you.